Hey guys, so we are at part two of day number 5. When we left off, you guys had just learned about our different ways of translating an absolute value graph, which we said is a V-shaped graph that starts out whose vertex is on the origin. We can see our different transformations or translations. And we actually have to put our skills into practice here with these 6. And so what I want to do is, I want to give you guys a chance. Let's write down these. Take about 10 seconds. Let's get these written down for me. These are going to be 4 functions that we're going to graph over here. So starting with our top one, y equals the absolute value of x. Well, hey, wait a minute. That's the OG. That's this one up here. We said that it's going to be a V-shaped graph whose vertex is at the origin. And when you go to graph this, you're going to see I did these in different colors. This one's in pencil, in green, in black, and in blue. So this one is the original, vertex at the origin. And then we go up 1 over 1, up 1 over 1. It's balanced. Up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. And so that would be your original. And the lines, of course, keep going on forever. So there's your original. Now, where do you guys think this one is going to go? Y equals the absolute value of x plus 3. Take a moment. If you have a pencil, you can try graphing this one in pencil. Well, it's just like the original. We start at 0, 0, except that then we add 3. If you add 3, that means you're moving up, moving on up. So we go up, 1, 2, 3. There's our new vertex. Boom. So you see when we translate, it moves the vertex, and that shifts the whole graph. So we go up 3, and then now, that's all we did. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. There's our new graph. Next up, we go to green. Bada boom. So this one, we got 2 things going on. We're going to go, looks like minus 2, that would be, okay, minus a number, we're going right. So right 2, and then minus 4 at the end. Anytime you're adding or subtracting at the end, you're moving either up or down. And if we're subtracting, we're going down. So right 2, down 4. 1, 2, 3, 4. There's your new vertex. Of course, you can get your graph going like that. All right. Last one. This one's in pencil. Y equals negative x plus 2. Okay. So let's deal with the plus 2 part first. That means we are going left 2. So we go left 1, 2. But then that negative means we are reflecting across the x-axis. So what that's going to mean is that wherever your vertex is, instead of opening up, it's going to open down. So we go left 2, there's our vertex, but now we open down. Boom, 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 boom. Oh. It's kind of funny, this one kind of bleeds over into our other one. Looks like that. Okay. And so that's how we graph these. You start at the origin and then kind of move depending on where they have us go. So let's do one more together, and then I'm going to turn you guys loose. Let's take a look at number 2 together. We're going to do this one together. Then I'm going to let you guys try these other 3 here. Okay, let's start with this one. So if you need to label, if it helps you to label. So we've got a negative, so we know we are reflecting across the x-axis. We've got a plus 1. That means we are going left 1, and then we have a plus 4 on the outside. That means we're going up 4. So let's follow the movement. So we start at 0, 0. We go left 1, up 4. There's your vertex. But instead of opening up, we're reflecting across the x-axis, so we open down. And there you have it. So I'm going to let you guys try numbers 1, 1, and 2. Go ahead and give these 3 a shot, guys. You can pause the video. All right, let's see how you guys did. On this one, we're going right 2 and down 4. So there's our vertex, and there's our absolute value. Number 1, we reflect, but first let's deal with the left 2, down 3. So we go left 2, down 3. And because we're reflecting, instead of opening up, we open down. What a great line. I missed completely. And then last one, number 2, we go right 4, up 3. Right 4, up 3. There's our vertex. And we're not reflecting, so we're opening up. All right, guys, we made it to the last part. And I really like this section down here. Check it out. What is an equation? So we're actually going to write the equation for each transformation. Where this is right here is our OG. So this is where we start at the origin, and we're going to transform this by adding some different things to this equation. So check it out. If we go up 3 and stretch by 6, I want to remind you guys, this is kind of like what our functions look like with absolute values. X minus, call it a number, and then plus a number. And A out front is stretch or compress. This in here, of course, is right or left, because it could be plus, it could be minus. This could be plus or minus, which of course deals with up or down. So do you see the pieces here? The number out front could be stretch or compress. The number inside could be right or left, and the number at the end could be up or down. And then of course there's a chance we have a negative out front, which means reflecting. So those are the 4 things here. Negative, number out front, number inside, number at the end. So if we're going up 3 and stretch by 6, the up's not going to come until the very end. That stretch by 6, though, we know is going to go out front. So you have y equals 6, absolute value of x. Are we going right or left at all? Nope. So close. And then we're going up 3. So plus 3. And that would be our new function. Let's do one more together, guys. Then I'm going to let you guys try and check out the last few here. So number 2, switch colors. We're going right 6, up 7, and reflecting across the x-axis. Okay. So y equals, start from the beginning. Not the beginning of the problem, but the beginning of the actual equation. If we're reflecting, that means that's going to go out front. That'd be a negative out front. Then we have a bar. X goes in there. Are we going right or left? Well, actually, are we doing any stretching or compressing? Nope. We're going right or left. We're going right. So minus 6. Close those bars. And then are we going up or down? Up 7. So plus 7. And so that's kind of how you create these, guys. So what I'm going to let you guys do, I'm going to let you guys try numbers 3, 4, and 7. Let's do 3, 4, and 7. We'll come back and check these in just one moment. We'll be wrapped up with some homework. All right, guys, let's see how you did. So y equals negative 0.9, and then absolute value of x, because we are reflecting across the x-axis and compressing. Both those go out front. Stretch by 8. Translate left 7, down 14. And then I almost messed up on this one. I almost didn't see that compressed by 1/3 at the end. We know that goes out front. If we're reflecting across the x-axis, that negative is the very first thing out front. Then we go right 6. That's minus 6 inside. And then up 17. We add 17 at the end. So guys, your homework. Our homework is going to be numbers 1, 3, 6, 7, 11 through 13, and then numbers 18 and 20. So that is 9 problems, guys. And this is on page 21 and 22 of day 5 homework. So thank you, guys. Go Jumpers.